Hi and welcome to the Distributed Systems Terminology, Common Concerns and Available Solutions crash course. This chapter is the second one in Terminology and Common Concerns, which is split across several episodes. This episode is about fault tolerance, reliability and recovery. I am Kobe and I say, let's get started. When discussing any system, not just a software system, we need to consider that the unexpected will sometimes become a reality. Things will go wrong. For any system, assuming that all actors are always available and functional will eventually be proven to be false. In this episode, we will present and understand the terms used when discussing distributed systems characteristics relating to the things can and will go wrong truth. This episode contains several definitions. I will present the terms in an order that makes understanding them simple. All definitions were written in the context of distributed systems and assumes that the software system as a whole is combined of multiple components, be it functional behavior actors, resources, or transitions of resources and data between different localities. Once we define the terms, we will then introduce the most popular distributed database, Apache Cassandra, and see how these terms relate to it. We will start with the definition for fault tolerance. Fault tolerance is a software system's characteristic which describes the system's ability to remain fully functional even when parts of it become unavailable. Sounds rather simple, right? If you recall the diner use case from the What is a distributed system episode, then we can say that as an example, losing a single waiter, due to illness let's say, does not render the diner unfunctional. All the tables will have to share the available waiters, one less now, yes, but the diner is yet functional. Let's move forward to the next term, recovery or recoverability. Recoverability is a software system's characteristic which describes a system ability to return to a well-described desired state after suffering a system component loss during normal operation. This one is a bit vague, I know. Let's clarify then. As we mentioned before, a distributed system comprises functional behavior actors, resources, and transition of resources and data among multiple localities. The aforementioned definition referred to any of these as components. So when we talk about recoverability, we refer to a system's ability to recover from the loss of a functional behavior actor, a resource, or any transition of resources or data among multiple localities. In the diner use case, for example, when a waiter called in sick, recoverability in this case would mean that the diner is able to add a replacement waiter to the diner once it became available, and get to its desired state of waiters count. Let us move forward to the last term we will cover in this episode, reliability. A distributed system's reliability relates to its ability to function as expected for a long period of time. Okay, Kobe, now you're just confusing us. Isn't that the expectation from any software system? Well, exactly. The definition is similar, but due to the various moving parts across multiple localities with distributed systems, that definition demands more of the designers of distributed systems. They are expected to design for fault tolerance and recovery mechanisms. To put it in other words, the reliability of distributed software systems is tightly bound to their fault tolerance and recovery capabilities. To put it in the terms of the diner use case, in case a waiter took an order to the kitchen and fell on its way there and broke her hand, the dining family at the table shouldn't know about it and the diner as a system should assign a new waiter to deliver the order to the kitchen. Wishing quick recovery and blessing of good health to the waiter which broke her hand. At this point in time, let us consider the real-life distributed system and examine its approach for achieving fault tolerance, recovery, and reliability. Apache Cassandra is a distributed software system aiming at providing database services for many users at the same time, managing large and constantly increasing volumes of data. In simpler words, it's a distributed database which allows modifying its scale at runtime to meet with its users' desired performance demands. For a deeper look at the technology, I invite you to check out the dedicated module for it in my Pluralsight course, Building an Enterprise-Grade Distributed Online Analytics Platform, which is linked below. For the sake of discussing how the terms fault tolerance, recovery, and reliability are achieved using Cassandra's distributed software architecture, I will describe it in several paragraphs. An Apache Cassandra distributed system is deployed as a cluster of interconnected storage nodes. Each such node is configured to know of other nodes, though not necessarily all of them. Using a gossiping functionality, each node tells its fellow known nodes about the nodes he is familiar with. After several iterations of this gossiping process, all nodes become aware of all other nodes in the cluster, whether they know them directly or through a mediator. Doing that, we will eventually get a cluster of nodes which are connected in a ring topology, a notion that is used in Cassandra for the sake of even data distribution across nodes. In Cassandra, each data row is considered a replica and is assigned to a partition, which is a data storage bucket physically stored on a single hard drive. This partition assignment is done by having a partition key assigned to each data row or replica. Cassandra will make sure to duplicate each replica to a desirable replicas count across multiple nodes in the cluster. An important notion to understand, due to the manner by which Cassandra calculates to which partition a replica belongs, any node in the cluster, once receiving a request to mutate, delete, or insert a replica, can determine which node is supposed to handle this request. By introducing this notion, the architects of Cassandra allowed for every node in the cluster to handle requests for any replica. This is very important, as we will shortly see. Let us consider how fault tolerance is implemented in Cassandra then. Given a specific node failure, a power surge which took the node down for example, all requests for replicas it stores are then served by other nodes, the nodes which hold the replica duplicates across the cluster. According to the configuration for how many duplicates per replica we would like to store and the given number of Cassandra nodes, we can mathematically calculate our fault tolerance to be a specific number of nodes failing before we risk data loss. For example, in a 3-node cluster and a replication factor of 2, we can rest assured that any single node failure will leave us with a valid copy of our data on at least one node. Recovery in Cassandra, assuming a single node becomes non-functional, will be handled as follows. The non-functional node will eventually become blacklisted, as the cluster will not be able to read or write to it. As we know per each node which data partition keys it is responsible for, and I remind you, nodes in Cassandra are constantly gossiping with their neighbors, any blacklisted node data will be replicated from one of the other replicas into another functional node. This is not a complete recovery yet, but it does recover our ability to remain fault tolerant to another node loss. To complement the recovery process, an IT personnel will have to replace the faulted node with a functional node. At this point in time, the cluster will rebalance itself and redistribute data across the nodes to share the load. Reliability in Cassandra is achieved in several manners. The first manner is that of duplicating data replicas across different nodes in our cluster. Losing a node then, and assuming correct cluster deployment practices were taken, does not hinder our ability to work with the data that node was responsible for, as it is being served from other nodes. The other manner in which reliability is achieved is by Cassandra's rebalancing process, which gets ready for an additional data loss automatically, by making sure the missing replicas are recreated on another node. To summarize this episode, I would like to recap what we've done. We began with acknowledging that things can and will go wrong. Then, we proceeded by defining fault tolerance, recovery, and reliability in distributed systems. Once these terms were defined, we continued with examining them in the context of Apache Cassandra, a popular distributed database. We understood how Cassandra's architecture implements fault tolerance and recovery, and by that, provides reliability to its users. As always, I am looking forward to hearing from you in the comments section. Don't forget to subscribe to the channel so you don't miss out on the next video in this Distributed Systems Terminology, Common Concerns and Available Solutions crash course. Thank you very much and see you shortly.